So amongst all these runs of the job, we see that this one has the best validation accuracy. So I'll actually go inside there and I can get the model as well. So this is the model that I'll be deploying. And how are we going to deploy this model? I already have a service that's written here. So if you look at the code, I have the app.py where I'm basically just doing API request handling. So I have this predict endpoint where I'm doing model.predict. And the way I'm loading the model in this code is using the ML Foundry library again, because remember we log the model. So we can actually fetch the model from ML Foundry library only, from TrueFoundry basically using ML Foundry library. And you do that by doing mlf.get client.get model. And you have to specify the model version FQN. So in the code, I'm actually taking that as an input, taking that as an environment variable here. So while we're deploying the code, we'll have to provide the environment variable with the identifier for the model, which is the FQN that we see here, right? So we'll do that. So this app.py is here. In the same repo, I have a file called req.txt, which is the requirements.txt file for this. So these are all the libraries that is required for the service. So these are the only two files that are relevant for this deployment. So let me show you how you can convert this repository of code into a service along with the model, right? So there are a couple of things you'll have to do. We'll have to fetch the model version FQN here. But before that, I actually have to get the GitHub repo URL. I go here, I press on new deployment. What I want to deploy is a service. So I click on service. Then I choose the workspace that we just created. And we enter the name as MNest service. And I provide the repo URL. It'll automatically pick up the branch names and the commit IDs. In this case, I want to keep it at main. Then how do you build this? It's actually Python code. As you can see, app.py is there and the requirements.txt is there. As instead I've called it req.txt, but it's the requirements file anyways. So how do I want to build this? The command to start this is actually ucon command. So I'll just get this from here. The way you start a fast API application, the framework that I'm using in the application is fast API. So to start that particular server, I need the ucon command. I'll give that as a command. And part two requirements are req.txt, as you remember from the repository here. And you have to provide the port for this. We can take a look at the app.py. So it's running in actually we just set that as port 8000 in the ucon command. So we'll set that as a port that we want to expose as well. The final thing we need to do is provide the environment variable. So we want to provide an environment variable with the name model version FQN. That is the name, and the value is the model from this particular run, which is the best performing run of all the runs corresponding to the job we deployed in the previous step. So this is the model FQN. So now the app will know which model to pick up from ML Foundry, from TrueFoundry using ML Foundry library. So then I can hit submit. This would start the deployment. For the sake of the video, I've already deployed a service. So you can see MNest service 1. If you look at the spec basically, or if you look at the form that I filled, it's exactly the same. The source is the repository, Python code, uvcon command, req.txt, port 8000, and the environment, and the model version FQN is the one corresponding to this. So I can just copy this again, maybe update this here again. So it's 3 actually. So I'll deploy this again, and it should not take a lot of time because I've not changed a lot of things. I just changed the environment variable, so the redeployment should not take a lot of time. So there are versions to this application. Previously, I've deployed this twice, and this is the third time I'm deploying this. You can see the build is completed, and it should start the deployment very soon. The rollout has started, so it should deploy the application very soon. And meanwhile, okay, it's complete as well. So you can see that the pods have come up. So version 3 is live right now. You can see the active status, version 3. So if I go to the endpoint, I should be able to see the application. Sure enough, the docs are there. This is the automatically generated Swagger OpenAPI page for testing Fast API application. This is something Fast API provides out of the box, and I can test the endpoints as well. And in the code, I had a predict endpoint, so I can try it out. I want to choose a file. I'll search for MNest image. As you can see, I have an image of a 5 here. Let's upload this and run execute. So you can see that it returns a bunch of probabilities, and for each digit, you can see the probability associated with that. And correctly, 5 has the highest probability, which is 97%. So it seems the model is working pretty well. So that's great. And if you go back to the screen, you can actually use the logs to debug anything that might be going wrong. So you can add logs to your application, and that should be visible here in this particular menu. You can also look at events. Events are actually things that are happening on the cloud that are conveyed to you. So if there's something that's not working as expected, you can either look at the logs, the events to debug effectively, and get rid of the issue super quickly. One thing that might be relevant for teams that is training machine learning models that deal with vision language models, basically bigger models, is the access to GPU. So when you configure the workspace, I showed you, you can either check or uncheck the GPU machines which is available within your cloud. So for example, while I deployed the MNest workspace here, I've enabled two GPU machines here. G4DN and G5 are machines with GPU in them. So I will be able to provide provision GPU for workloads that are running in this particular cluster. So let's go back to the job that's deployed in this workspace, the MNest workspace. I go to the job here and I click on edit, and I come down here to the resources section. So here I have the GPU type field. So let's say I want to train this model on one of these GPUs, let's say NVIDIA K80. Then I can choose that particular GPU and I can choose the count as well. And once I do this, and if I'm happy with the configuration, then I can go ahead and submit. And for the job running on this particular, for this particular job, you'll have access to GPU and your code can be configured to use that as well.